Hello everyone and welcome back. My name is Mr. Cobalt and in this video I'm going to go over how to identify organic compounds. So let's get into this. So on the board you can see I have a bunch of organic compounds written down with their structural formulas. And so we're going to identify what group each of these compounds or organic compounds belong in. And so the key is that you're going to identify what functional groups are in the molecule. So the functional group will tell you what kind of organic compound it is and what group it belongs in. Hence the name functional group. So with regard to that, I'm going to identify, not only am I going to identify what group they're in, but I'll show you what the condensed formula is and also the line drawing for each of these. So that way you can familiarize yourself with those as well. Okay, let's start with A. So the first thing is you don't see anything in this formula, you don't see anything in this compound other than single bonds of carbons and hydrogens. And so that's a dead giveaway that this is an alkane. So this is in the alkane groups because an alkane is a carbon, an organic molecule that only has double bonds. It only has carbons and hydrogens in it. So this is an alkane. So we'll identify this as alkane. Okay. And so the condensed formula would be basically you're getting rid of the lines and you're just putting the hydrogens and carbons together. So the way you would write it is each group is separated, written separately. So this is a CH3, CH2, CH2, and so on. So this would be oops, hold on a second. Let me write this a little bit higher up. So this is going to be CH3, CH2, and how many CH2 groups? I have 1, 2, 3, 4, 5. So 5 CH2 groups. So, oops. Sorry about that. So I can either write out all of the 5 CH2 groups, or what I can do is to make it more condensed is to put parentheses around the CH2 group here and just put a 5 there. So that indicates I have 5 CH2 groups in a row. And so then, let me make this clearer. And then it ends with a CH3 group. So I have another CH3 group at the end like that. All right, so what about the line drawing? So in a line drawing, we treat the ends of our molecule. If they're carbons, then it's just the end of the line. If you have a corner with nothing there, then it's assumed to be a carbon. So we have a zigzag line. So this is just carbons and hydrogens. And we don't write hydrogens in our line drawing, but they're there, right? So, but we just don't draw them. So this line drawing for this, we have 1, 2, 3, 4, 5, 6, 7. So the way it would look, it'd be start with a line. So that end is a carbon, and then we make a zigzag. So that corner is a carbon, and we keep counting 1, 2, 3, 4, 5, 6, 7. So that would be the line drawing of this alkane. So we have a carbon at each end, and we have a carbon at each corner. And the hydrogens are assumed to be there. So we should have 3 hydrogens here, 2 at each of these, because remember, carbon bonds 4 times. So if we have this carbon here is bonded once to that carbon, so that means there must be 3 other hydrogens bonded to that carbon that aren't being shown. Okay, this carbon here is bonded to that carbon and that carbon, so that's 2 bonds. So that means that this carbon must have 2 hydrogens bonded to it to get the 4 bonds. And so that's the understanding of these line drawings. Here we have this group here. So when you have this group here, or not necessarily that group, but whenever you have a nitrogen bonded to at least one R group, and an R group is just some carbon chain group that is bonded to your nitrogen, and the others two could be R groups as well, or just hydrogen. But in this case, we got two hydrogen and one R group, and so this would be an amine. So this belongs in the group of amines. And so again, we would draw the same thing. So condense this. So this would be condensed NH2, right? And so, or you could have, yeah, NH2. And then you have 1, 2, 3, 4, 5, 6, 7 CH2s. So I would put CH2 in parentheses with a 7. Let me count 1, 2, 3, 4, 5, 6, 7. And then we have this CH3 group, so that would be CH3. So that would be the condensed formula. And then the line drawing would be, since the beginning here is an N, we're just going to write N with a hydrogen at the end. And then the carbons are just going to be lines. So we have 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. So that would be the line drawing of this molecule here. Now here, since we have this here, we have an oxygen, and bonded to the oxygen are two R groups. We have R group here and R group here. They can be the same, they can be different. Here they're the same. But then this identifies this as an ether. So anytime you have an oxygen with R groups bonded to both sides, not hydrogen, but two R groups, then that R group is going to be, this molecule is going to be the ether. So we have here an ether. So again, the R group cannot be hydrogen. If one of these R groups was a hydrogen, you would not have an ether, you would have something else. So be aware of that. So this is an ether. And so for this condensed formula, we're going to have CH3 with CH2 groups. So we write CH3 and then CH2, 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 right? So then we can have CH2 parentheses 3. And then we have the oxygen, right? And then we have the CH3, CH2, 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 CH3 again. So here, we don't need the lines here. We can just put the oxygen, right? So it'd just be O followed by, and then we have CH2 with 3, and then CH3. So that would be the condensed formula. And again, you can write out the CH2s. You could have CH3 and then write out CH2, CH2, CH2O, CH2, 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 CH3. It's up to you. But this is, I'm just saving space because I don't have a lot of space. For the line drawing, it would again be carbon chain here represented by lines. So we have 4 carbons here. So we're going to have 1, 2, 3, and then 4, and then a line to oxygen, and then we're going to have another 4. So 1, 2, 3. So we 1, 2, 3, 4, and so we have lone pairs on the oxygen. So there's your line drawing for this molecule. Next, we have this molecule, and so the function group here is going to be this right there. We have a carbonyl group. The C double bond O is a carbonyl, and we have it bonded to an oxygen. and then we have R groups bonded on both sides. So whenever you have something like this, the R groups cannot be hydrogen. So if you have, well, this one can't be a hydrogen. This one can be a hydrogen, but not this one. So in this case, this would be an ester. So this belongs in the group of ester. Okay. So in this case, the condensed formula would be CH3, CH2, and then we have this C double bond O, that would be CO2, so O2, and then 1, 2, 3, so it'd be CH2, and then we could write it out, CH2, CH2, and then CH3. So we could write it out that way. So that would be the condensed formula. And then for the line formula, it would be these two carbons, right? So we have 3 carbons. So we're going to have 1, 2, 3. So 1, 2, 3. This third carbon is bonded, double bonded to an oxygen. So we could do that. And there's 2 lone pairs. Oops. Let me make that better. 2 lone pairs there. And then this is an oxygen, so that's bonded to that oxygen. So this carbon is bonded to that oxygen as that oxygen. So we can put our lone pairs there. And then we got our 4 carbons. So this would be 1 carbon, 2 carbons, 3 carbons, 4 carbons. And so that would be the line drawing for that molecule. So next we have this group here. Notice that when you have a carbonyl group, again, the carbonyl group is a carbon double bonded to an oxygen. This carbonyl group is bonded both sides by an R group, and they can't be hydrogen. So the R group has to be some carbon chain of some sort. So in this case, when you have a carbonyl with 2 carbon chains bonded to both sides, that is a ketone. So this is a ketone group. And again, the condensed formula here would be CH3, CH2, then CH2 again, and then we have that CO. So it'd be CO followed by CH2, CH2, so CH2, CH2, oops, I'm sorry, CH3, so CH2, CH3. And so that would be the condensed formula, and then the line drawing would be 3 carbons. So we have that carbon chain, so we're going to have 1, 2, so 1, 2, and 3, that's 3 carbons. And then we have that 4th carbon here with the carbonyl group. So we're going to have a double bond O with 2 lone pairs. So there's our carbonyl group. And then we have 1 carbon and then the 2nd carbon there. So this would be the line drawing of this molecule. Once again, here we have this group here, this C double bond OH. Whenever you get that C double bond OH, that is going to be your carboxylic acid group. And so this is a carboxylic acid. Carboxylic acid. And so the condensed formula for this would be CH3, CH, and then CO2H. Or sometimes you see it as COOH written out. So then that would be the condensed formula for this molecule. And then if we write out the line drawing, we'd have 3 carbons, 1, 2, 3, and then we'd have our double bond O, and then we'd have this bonded to an O there. So we have our lone pairs, And here we have our lone pairs. And then we'd have this bonded to a hydrogen. And so that's the line drawing for that molecule. Finally, for this row or column here, we have this molecule. And so here we have a carbonyl group bonded directly to a nitrogen with hydrogens. It's like an amine group, right? So we have a carbonyl bonded to this nitrogen with two hydrogens. So anytime you have a carbonyl bonded directly to a nitrogen here, this is going to give you something called an amide. So this is an amide. So that would be the amide group. And so we would condense this by writing. So notice here that this carbon here has two CH3 groups on it. So we can write the CH3. We can write parentheses and just put a subscript 2. So that would be CH3 2 followed by C. So that's C there. And then that's bonded to CO. And then NH2. So that would be the condensed formula. And so here, your line of would be something like this. You have this carbon here, and off of that carbon is 2 groups. So if this is your carbon, you're with the carbonyl here. Let me write this a little better. So here we got our carbon. So this carbon is bonded to this carbon, so we'll have that. And so that's bonded to an oxygen. And then this carbon is bonded to 2 carbons that are branched from each other. So this one would be this way and this way. So you got a CH3 group there, CH3 group there, and then you've got the C double bond O, and then you've got that bonded to a nitrogen with its lone pair, and then it's got 2 hydrogens on there, so you could just put the H2 like that. And so you have your line drawing with of this molecule. So don't forget the lone pairs on the oxygen. Okay, now we're coming up here. So this molecule has this group at the end of it. You have a carbonyl group with a hydrogen directly connected to the carbonyl. It's at the end, and so that is going to be an aldehyde. So this is going to be an aldehyde. And that's your functional group for aldehydes. Here we have 1, 2, 3 CH3 groups. So the condensed formula would be CH3. Oops. Let me write that better. CH3 parentheses with a 3. And then those are all bonded to that carbon. So we have a carbon following that. And then we have a CH2, CH2. So CH2, CH2. And then after that, we have the carbonyl group. So that would be CO, a CHO is the way we would write that. We don't want to say, oops, let me fix that. We don't want to say COH, because if you wrote COH, that would indicate an alcohol, because OH is an alcohol group. So to prevent that confusion, we write the H first, because the H when it follows the carbon, the H is bonded to whatever atom it immediately follows. So we write the H after the carbon to indicate that that H is bonded to the carbon, not to the oxygen. And so then the oxygen comes next, indicating that that is bonded to the carbon as well. So CHO, anytime you see CHO, that's going to be indicate your aldehyde group. Okay. And then the line formula is going to be, since I have this carbon here, I'm going to have 3 branches off of that carbon. So I'm going to have that carbon there. And so I'm going to have a branch there and a branch there. So there's that carbon bonded to 3 CH3 groups. And then I have 2 carbons there. So this one's going to be bonded to a chain of 2. So that one's going to be 1, 2. And then the third one is there. The third one is bonded to an oxygen. And then you've got the hydrogen coming off of there. So that would be the line drawing for this molecule. For this one here, you'll notice that this group here, this is your OH group there. Your OH group is a dead giveaway of an alcohol. So if you see an OH group, you've got an alcohol. So this is an alcohol. And so the condensed formula here, so here I have, off of this, I have CH2 or CH3. So the way you write this would be CH3, and then you have C, and then you have OH, COH, COH, and then you got these and then you have CH2, CH3. And then to draw the line drawing, you start with you have these 2. Oops, I forgot that methyl group there. Sorry about that. So here you've got 2 methyl groups there. So what you could do is you could put a parentheses around the CH3, put a 2, and then you've got COH, and then CH2, CH3. And then the line drawing would be, again, you have these 2 methyl group branches off the carbon. So you've got this chain here. So you've got 1, 2, 3. So there's a 1, 2, 3 carbons. That's the 3rd carbon. And then you have off of this carbon, you have the alcohol group, which would be OH. I'll do it like that. OH, and then you have your 2 methyl groups off of that one. So you'd have this kind of is the way you would do that. Maybe I can do that better. So if I have a 4 chain here, so I can do 4, 1, 2, 3, 4, and then off of this second carbon, 1, 2, off this carbon, I have an OH group, OH, and then I have the methyl group off of that way. That might look a little better. Okay, so for this one, this I have a double bond here. So anytime you have a double bond, that's going to be an alkene. So we have an alkene here. Oh, by the way, you should put a hydrogen here. So that way you identify it as an aldehyde. So don't forget the hydrogen like I just did. Okay, so this is an alkene. And so in this case, we have a 1, 2, 3, 4, 5 carbon chain. So we're going to have 1, 2, 3, 4, 5. And we have a double bond between the second and third. So 1, 2, so here. So we're going to draw a double bond there. And we have a methyl group off of the second one. So we draw a line there. And so this would be the line drawing for your alkene. For this one, notice we have this nitrogen here that's bonded to 3 R groups. So here we have an amine again. We had an amine up here. Notice we have nitrogen bonded to 2 hydrogens in an R group. Here we have the nitrogen bonded to 3 R groups where they're all carbon chains of sort. Nothing is a hydrogen. So then the condensed formula would be CH3, CH2, N, and then you'd have CH3, 2. And then you have your, you don't need the lone pairs actually. So that would be the condensed formula. And then the line formula would be, we have the carbon here, carbon there, this would be your nitrogen. And then we have that bonded to a carbon like that, and then bonded to a carbon like that with 2 lone pairs. And so that would be the line structure for K, for that amine. Okay, next we have this one. Here we have this triple bonds. Triple bonds are indicative in alkynes. So this group, this is in the alkyne group. And the way we would draw this is going to be, the condensed formula would be CH3, C, and then we have these 3 methyl groups, CH3 groups are bonded to here. So we're going to write CH3 in parentheses with a 3 subscript. And so here we have CH3, C, and then, oops, I forgot a C. So C, right? So we have CH3, C, and then C, and this carbon has 3 methyl groups, CH3 bonded to it like that. So this would be the condensed formula, and then the line formula would be your this one, these 2. So we have 1, 2, 3. So here we have a triple bond, like so. So this would be your 3rd carbon between your 2nd and 3rd here. And then your 4th carbon is here. And then off of this 4th carbon, you'd have 3 methyl groups. So carbon, triple bonded to carbon here. And then you got your 3 methyl groups. And then finally, we have this one. So this is an arene because of this here. This makes it an aromatic, or arene. And so we would condense that. And so the way we would do that is going to be CH3, C6, excuse me. Sorry about that. So this is going to be C6H6, and then you have your CH3, and then the line drawing is going to be the same thing. You put a circle here. This represents that, and then you just have the 2 lines like that. And so that's it for this video. I hope this was very helpful. If you enjoyed the video, then please like, share, and subscribe to my channel. Hit that notification bell, and then put a comment down below. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me and have a great day.